So the next speaker is Chris Wiggins. Chris Wiggins is an associate professor of applied mathematics at Columbia University and chief data scientist at New York Times. At Columbia, he's a founding member of the executive committee of the Data Science Institute and of the Department of Applied Physics and Applied Mathematics, as well as the Department of Systems Biology, and is affiliated faculty in statistics. He's a co-founder and co-organizer of hackNY, a nonprofit which since 2010 has organized once a semester student hackathons and the hackNY Fellows Program, a structured summer internship at NYC startups. Prior to joining the faculty at Columbia, he was a Courant Instructor at NYU and earned his PhD at Princeton University in theoretical physics. He's a fellow of the American Physical Society and is a recipient of Columbia's Avanessians Diversity Award. And today he's going to talk about a decade of developing and deploying machine learning at the New York Times. Chris.
Thank you very much. Thank you very much for having me and for all the amazing previous speakers. As advertised, I'm Chris Wiggins, splitting my time between Columbia and the New York Times. Previous speakers were fantastic. Mark, our last speaker, said that it would be a difficult act to follow. I claim that this will be an even more difficult act to follow because I will be telling you about machine learning at a company that is much tinier than the previous companies and far, far older. And at the same time that our relationship with machine learning is actually only about 10 years old. So I'll be telling you about 1 decade of developing and deploying machine learning at the New York Times. Okay, so the first thing, I'll tell just a little bit about the content of what I'm going to talk about today. The New York Times has a long-standing reputation in people's brains. Since 1851, they have a conception about what the New York Times is all about. It's a B2C company, right? It faces normal people. And so when you think of the New York Times, you probably think of news. The news is complicated. Our last speaker talked about the value of verified content, but also the contestation of what has been verified. So I'm not going to talk about that. Instead, I'm going to tell you about the org chart of the New York Times, which is basically church and state. Church is everyone who possesses and defends the craft of journalism, and state is everything else. And the problems I want to talk today about are about state. Not about so much projects where we work with editors on using machine learning for editorial concerns. Now, the New York Times, like I said, has about a 10-year relationship with machine learning. It has an older relationship with the digital. In some ways, the New York Times is, as I said, a very old company, born in 1851. This is a picture on the left of the birthday photo of the New York Times. And as a digital company, in some ways, the New York Times was born on January 22nd of 1996, when the New York Times introduced a website, which they reported on with the quaint headline, "The New York Times introduces a website," as you can see on the right-hand side. And as you may know, if you've ever stood up a website, that is a chance for abundant communication with people, because a a website, which people in the 90s thought of as sort of a digital shingle or a digital manifestation of your company, is actually a conversation. It's actually a tremendous exchange of interaction and data between you and everybody who visits your website, as well as all of the other digital properties. So every time you visit any electronic experience, you are having a conversation. Whether you know it or not, the device is having a conversation with some web server somewhere else. And that is an abundance of data. And that has been, there are companies like LinkedIn, we heard from earlier today, where my understanding from early LinkedIn people is that one of the first things they thought about is how are we going to track every event. That was not so much thinking of the New York Times. Event tracking was born only around 2012 or so, with a bespoke solution which was called Event Tracker. And around the same year, the New York Times created its first team to gather all of the data that you were having from all of those digital interactions in a team called Business Intelligence, which some of you who know the history may know that that's a term from 1958. So the relationship with collecting data at the New York Times is not as old as the New York Times itself. That said, the last decade has been one of amazing digital transformation in which people are interacting with the content via the web, via tablet, via mobile device, and the type of content that they're interacting with is not just articles which are designed to be the rough draft of history, as journalists sometimes say, but also games content and audio content and cooking content, even product recommendation content, a wide variety of content, each of which has a very different relationship with engagement and a different structure in terms of how you might architect that as a data set, so to speak. So this is not a new observation. One of our earlier speakers, I'll give away the punchline. So it is not new that every time you interact with a digital property, you are leaving lots of digital breadcrumbs, and it is not a new observation for companies that although the social activities generate large quantities of potentially valuable data, or rather, the data were not generated for the purpose of learning. However, the potential for learning is great. And you may think, oh, this is a quote from 2020 or from earlier, but it's actually from 1993 at Bell Labs, which Deepak mentioned in passing the impact of Bell Labs on technology companies of the day. But there are some companies that have realized for a long time that every time you have a digital interaction, that's an opportunity for the company to learn from those data and to improve the product. Okay, so I'm going to tell you specifically about some projects in the group called Data Science at the New York Times. So I founded this group in 12 years ago, maybe 11 or 12 years ago. Originally I said maybe we should call it the machine learning team, but after discussing it with people, people didn't really know what machine learning is. Data science seemed more like it. And the data science team is really about developing and deploying machine learning. And I'll tell you about a couple of projects. It's a team of about 20 plus people. And roughly, we've broken the team into projects that are around creating advertising solutions that make the New York Times worthy of marketers' dollars, algorithmic recommendations, which is something we've talked about a bit today around Rexis and content recommendations and generally recommending any long tail of things. A media innovations team that thinks about how do we go about making sure that when we do purchase pixels on other companies, so if we're putting paid advertisements somewhere, how do we do that efficiently? I won't talk about that today, so I'll just briefly say, a long time ago it used to be done based on whatever the guesses were of young marketing people, and now it is done using Python. So we've tried to take media and the way that we buy media and turn that into an optimization problem. But I thought I'd start talking with a group called Algorithmic Targeting, which you can't exactly tell from the name of the group what it's about. But it's about basically getting more subscribers and getting those subscribers not to stop their subscription. So let me talk a little bit technically about what goes on in that team in particular. So I'll start out with content which appeared in a blog post. Again, it's a smaller team. Our work is not appearing in technical journals as we may have come from as academic backgrounds. Instead, we're putting our things on a New York Times blog post about technical aspects of the New York Times, which we find does get read. So one in particular blog post was this post about how to use machine learning for the paywall. So I'll try to explain why the paywall is central to the New York Times, and then how we put machine learning to work for that. So it was realized by many journalism properties around 2009 or 2010 that advertising was going away. And what I mean by that is, for multiple centuries, the craft of journalism has been tightly coupled to the business of newspapering, and the business of newspapering has been about advertisement. And I didn't include the graph in this talk, but you can look at a graph of dollars of advertising going to magazines and newspapers by year, and you can see that everything is great in the 90s, and then something happens around 2000 and all the money just goes away. It's a clear effect for anyone who studies natural systems. You can see that something happens, and then you can plot on the same graph the money going to Facebook and Google. You can see where the money is going. So by 2010, publishers were realizing that an advertising model, a digital advertising model, was no longer sustainable in journalism. So the New York Times went in with an experiment that maybe people would be willing to pay for content. Now in 2025, that seems less radical, but in 2011 it was widely frowned upon. It was not believed that people would pay for content. It was still believed, as Stuart Brand famously said, that information wants to be free. Or as Goldhaber said in an article on the information economy in 1996, that if you're charging people from your content, that you're doing it wrong. The full Brand quote is actually, sometimes information wants to be expensive. Most people don't remember that sort of downer end of the paragraph. The first part of the paragraph is right there. So many people, including smart people in media, thought that it was a bad idea to try to charge for content. It was not a time in which people were paying for Spotify and Netflix and other things like that. Paywall is destined for failure. Here's reasons why the New York Times paywall will fail, and it's really dumb. In fact, the paywall has worked out okay, and so that's one of the lessons of the last decade, is that in fact people are willing to pay for content if you work really hard at differentiating the free and pay experience, if you provide content that is valuable, and valuable of course means that there's something that people find in the content that they can't find everywhere else. So you need to have some sort of differentiated experience between free and pay, and you need to provide something that people are willing to pay for. I should say a recent, and by recent I mean this very morning, update on these numbers is from today's earnings call, at which digital subscribers rose to almost 12 million. So it worked. So I want to talk about how machine learning has fit into getting that to work. And it's not entirely obvious, because if you think about something like advertising as a business model, it's easy to attribute the relationship between the digital decision of the algorithm and money. For example, if the digital decision of the algorithm is which advertising to put up, then it's easy to attribute that decision to a reward in the reinforcement sense of the word, right? You have an action, you have a response, and it's pretty easy to attribute the response to the action, because you put up an ad and either somebody clicked on the ad or didn't look at the ad, and then you know whether that ad was good, right? If it got a click, for example, and if you're being paid by the click, then that's easy. Much harder with subscription, right? So with a subscription service, it's more challenging to run your company using machine learning, because you have many different actions, and then the reader will experience many of those actions over the time that the reward is delivered. In some ways, the reward is delivered for 2 years or 3 years, as somebody continues to choose not to cancel their subscription. Or if somebody's experiencing the content for weeks before they decide to actually become a paid subscriber. It's ambiguous how you would go about associating action with reward in the usual reinforcement learning sense of the word. Phrased in the language of business people, there is a large funnel. At the top of the funnel, there's many, many people who have ever heard of the New York Times. There's a smaller set of people who have visited the New York Times, a smaller set of people who have registered for the New York Times, they've given up their email address, and then a much smaller set of people who have paid to subscribe to the New York Times. There's a missing part of this funnel, which is people canceling their subscription to the New York Times, but that is another part of the flow that you would like to optimize. The question then is, how can we use a type of machine learning which we like to call prescriptive? And it's a useful adjective to use when you're working with people who are not coming from a reinforcement learning background. Because if you're not coming from reinforcement learning and you've seen the headlines over the last 15 years that, you know, machine learning can tell if the picture has a cat face in it or not, or machine learning can predict who's going to cancel their subscription, you may think that that's the goal, to predict who's going to cancel their subscription. But of course, that's not, right? It's like having a hospital that never gives anybody any medicine, and then you predict which patients are going to die first. Of course, the doctor doesn't want to know who's going to die. The doctor wants to know which patients should I give which drug to. So that's been part of the culture change over the last 10 years, is to explain to our business partners, our editors, our product people, that what they want is actually not a model that predicts what's going to happen in the absence of treatment. What they actually want is a model that will tell them the optimal treatment in order to drive the outcome they want, and then to work with them to develop the appropriate science to get that done. So we're calling that prescriptive learning, internal to the team. We often speak about it in the language of reinforcement learning, which, as a speaker earlier today said, is a good idea. I guess that's another punchline for the talk, is reinforcement learning is still a good idea. Okay, so what do we mean by prescriptive in the case of having a paywall or a digital paid subscription service more generally? Predictive machine learning would be what will happen without some sort of intervention. That's a very common form of supervised learning. For example, you might look at somebody and all of their digital engagement with the product, and then you could predict if they become a subscriber, or for the subscribers, you could predict if they cancel. That's useful. You could know who are the at-risk individuals. You might have an interpretable model which will tell you the risky behaviors, but it will not tell you what lever you should pull and what setting you should set your lever to if you actually want people not to cancel their subscription. The way to do that is by having some sort of prescriptive sense of what you're trying to get out of machine learning. The best way to do that is a way that Fisher evangelized in the 1920s, which is actually to do experiments. That is, in general, you have to be willing to do things with some randomness in order to explore and then to exploit. So that's been part of the I would say the culture change at New York Times, is to encourage more people to think about being willing to do things at random. Even though they may pay some tuition in the short term, they will learn what is the optimal treatment. And of course, if you use the medical analogy, It's easier for people to understand. We don't give COVID vaccines to everybody. Instead, we do a randomized control trial with random vaccines to random people, and then we learn from the data what is the optimal effective policy. Okay, for example, for us, that would be whether the user subscribed based on at what point we provided a digital paywall. So we typically, of course, don't know those counterfactual universes. We don't know what would have happened if somebody would have been asked to become a subscriber after 1 article or 3 articles. We only know what happened with 2 articles for that person. But if we've done a randomized control trial and we've learned some relationship between attributes of the person, which action was done, and rewards, then we can build a predictive model of what is the best policy. Okay, so this brings us to subscription. I said earlier that one of the challenges in moving from an advertising model to a subscription model, first of all, there's the normative challenge of just convincing people to pay for content, which I think was a bigger challenge 15 years ago. But the other is that you don't have immediate association between reward and action right now. So, for example, when you think about introducing people to the content, you have to market the content, you have to get people to experience the breadth of the content. Some people may decide they like news or opinion or games or Wirecutter or lifestyle journalism or now The Athletic. There's a wide variety of content that people are exposed to. And the hope is that once people have experienced a breadth of content, then they will have some moment where it's the appropriate moment to ask somebody to become a paid subscriber. The goal that the company had set was by 2027 to get to 15 million. As I said, it's almost 13 million as of this morning. Or did I say almost 12? Anyways, we're on the way. So that we want to do that in a way that's consistent with the mission to help people understand the world and to seek the truth. And so the language you'll hear in many of these companies is that we want to balance between engagement and conversion. Conversion, it's pretty real clear what we mean. A dichotomous Boolean binary variable, are you or are you not a subscriber? Engagement, on the other hand, could be almost anything. Right? It could be any metric for the way people engage with the product. And that some of those are based on the dreams of the product people, some are based on the ways that we as employees actually use the product. Some of them are based on what can you easily query from a database at scale. The combination of those is going to be something that leads to signal. So using randomized control trials, as I indicated earlier, is the best way to actually learn a causally valid predictive policy. Again, if you do things just based on observational data, you will never know if, by analogy, your doctors have only given the expensive drug to rich people and they've never given the cheap drug to poor people or something. You won't know what is the right relationship if all of your signal is correlated with the action. Okay, so we do this in the case of the paywall by doing a randomized control trial. I'll phrase it in a language from several years ago. We've updated things quite a bit since then, but for example, you could imagine that somebody is given less friction or less paywalls, other people are given more paywalls, and then you can tune whether or not it's important for people to engage with the content and be exposed to a lot of content now, or you want people to get as many subscribers as possible right now. And in fact, that's a Pareto problem, right? It's a multi-reward system in which you can decide how much you want to balance those things. And the you often is not me. The you often is somebody who's the senior vice president of growth, and it might be based on, what are the business concerns right now? What are people's feelings about how much people are engaging with the news cycle? How valuable it is to get a lot of subscribers now versus how valuable is it to get a lot of new people introduced to the content now? So we actually provide people, our business partners, a graph that says, here's the efficient frontier. Here's what's doable. Now, to do that, of course, we've done randomized control trials. We have built certain models. The models could be whatever you like. They can be deep learning models, any supervised learning models you'd like, to predict what's going to happen in the presence of different treatments. And then we show people something and allow them to tune a knob to go from one attribute to the other. I've presented it as though the only things are engagement and conversion, but as you can imagine, if you have a website that also has a registered state, then you might want to balance between anonymous readers becoming registered, anonymous readers become subscribers, registered become subscribers. You might have constraints like you want to balance this amount of content with this content, so there's actually multiple knobs, which is a really fun problem to dynamically learn the right knobs that meet all of the guardrails at their right values. But for the sake of this slide, let's just say there's one knob, and our business friends are allowed to tune that knob to change the level of the different trade-offs. Again, you might want to do that because if you have a relationship between people discovering the content now and becoming a subscriber later, you may not want to maximize just total number of subscribers right now, which has a rather trivial solution. You simply just crank the knob. Okay, so how might you do this? You can do this by leveraging straight up supervised learning. If you have delivered the treatment at random, then the treatment variable becomes a covariate. You can do this in multiple ways, but you can develop a model for predicting different people's engagement, different people's propensity to become a subscriber, and then you can tune a knob that says how much do you like those different things. This allows you to do things in a way that's sort of dynamic. You learn the model once and it's very slow and expensive, but you can tune the knob quickly, rapidly to change what the optimal policy is. And by rapidly, I don't mean once a month. I mean, you could be doing this every 15 minutes or balancing your cloud spend. Basically, how much do you want to spend on recomputing the optimal policy? Okay, so I'll show you some totally fake numbers, but in reality, you actually can see that you, as our business friends put it, defy gravity by lifting off of the line that's defined by what a random policy would do, a policy that knows nothing about the readers and just chooses between delivering paywalls or not at different frequencies. Of course, how do you backtest? How do you know what would have happened in a counterfactual universe? Well, fortunately for us, probability still works. What we really did was, under a randomized control trial, we delivered a certain thing to a certain person, but we can test how well a new model would have performed by looking at the subset of people who delivered, or who received the treatment that this new model would have delivered. Doing that is a way that you can think about as inverse probability weighting. If, for example, you're comparing to exploration data that had some had some random policy, but not the policy that you're planning to deliver, but you'd like to test it under some new policy, also possibly random. Math tells you how to do this. If there's a term for this from the 60s called Hayek estimation, which was really coming from survey design. Think about how you accommodate the fact that when you send out a survey, you get a subsample of people and you might want to rebalance things. But it's based on causal ideas in probability, that you have a probability distribution of all the things you were allowed to know before you made a decision. Let's call that X. A, the action you took. Y, the vector of responses that you might want some weighted combination of those responses in order to validate. Alpha here is a subscript that you can think of as indexing last week and next week, or you can think about it as some other hospital with some other crazy doctors versus the new hospital that wants to use the health records from the old hospitals. The causal part of this statement is that the response variable, P of Y, given the action, and X, and the prior, sort of the distribution of patients or readers coming to your website, P of X, is not a function of the policy. Alpha indexes all these different policies. So that allows you to do some propensity weighting that can estimate how well a new model will perform given data that were drawn from some different exploration policy. And this is, I would say, well known in the reinforcement learning literature. There's a subsection of the reinforcement learning literature where this is a very important observation. What does this look like in terms of mathematics? Well, it means that you can take an estimate of how well something will perform in the future. Again, these ideas were developed originally in the 50s and 60s for survey design. One of the originals was HT, the Horvitz-Thompson estimator, which has this unfortunate property that it doesn't actually preserve mass, which is a normalization of probability, I should say, which is why we use the Hayek estimator instead for many of these problems. And the P that's listed here, P of A given X, could be a randomized control trial, or it could be any other exploration policy that you've done, which means that in principle, you can make the world better and better by always doing things at random. As your policy gets better and better, you will be driving up some key performance indicator you care about. Okay, so we have how the model would have performed in the past if we would have done something else. And now you can estimate the new model's performance under the new policy because you believe that some of these terms, the response and the distribution of readers, will stay the same. By the way, those statements have a causal modeling assumption in them. You may not believe that readers behave the same way 15 minutes from now or 3 months from now. You may believe that as the news cycle changes, it's actually a distribution of readers showing up. And therefore, it's a good idea to build out the infrastructure that allows you to keep doing this rapidly. So having an always-on RCT is far, far better than having an RCT once if you believe that effectively the laws of physics are always changing, which is true for any digital company, particularly a news company. It's got the word new right in there, so things are always new and things are always changing. Okay, so that's a statement about the paywall and delivering prescription. Let me make some statements about content recommendations, which I think will overlap with some of the things that were said in previous talks. The New York Times also has been experimenting with a recommendation system for a while. It first launched in 2011 with this little press release that says the New York Times adds recommendation features. At the time, it was limited to one location in the digital experience, so sort of on the lower right-hand side of the homepage, there was a wee little section called Recommended for You. You can still go to the archive Wayback Machine and see a screenshot of it. It was a structureless feed, just undifferentiated, so it could be, you know, opinion, book review, hard news, something else, all just sort of structured, without structure. One question to ask is, what actually are we optimizing? A previous speaker brought up the Netflix prize from 2000, end of the year 2006, if I remember correctly, beginning of the year 2007. People got very excited about this idea of predicting the number of stars of a movie review. It's a great history to go read about the history of the Netflix prize. And a reasonable question is, what are we trying to optimize? As you know, we, the academics who worked on that, is predicting the right number of stars the thing that's directly going to drive profit for Netflix? Deeply unclear, particularly given the fact that they never actually implemented any of the winning algorithms. So the way we've approached it at the New York Times is as an optimization problem. So an optimization problem, and this has been known since arguably the 1940s under statistical decision theory, is that optimization in a world where you don't know how the world works necessarily means trying things out and then exploring in such a way that you can exploit later. So a nice blog post about this is a blog post about using algos for recommendation systems from 2019, in which we explicitly said we're using a contextual multi-arm bandit. So I'll say a little bit about multi-arm bandits for those of you who may not have encountered the idea. The term itself is from, the term bandit, I should say, is from 1955. This is a fact which doesn't, I never see anybody use this figure, but if you, in the bandit literature, people say bandits all the time. I don't think they know that actually it was proposed by the statistician Mosteller in 1955, where they were doing experiments on undergraduates, presumably at Harvard. So presumably Harvard undergraduates were asked to press buttons on this physical device to try to get as many coins to come out of it as possible. And they called it the two-armed bandit because in parlance, bandit is another word for a slot machine. So if you go to Las Vegas and you play a casino, one of the things you can do is you can pull this thing that may or may not give you a coin. Probably not. But you have to learn from the data from pulling different arms, which is the one-armed bandit that's going to give you as much money as possible. So Mosteller called this the two-armed bandit because you have two different buttons you can press. And then there's this tantalizing footnote in the footnote says, the optimum decision rule or the best strategy for playing the two-armed bandit for end trials seems not to be known. So this is from the psychology literature, who's not really a big topic of study in computer science or statistics. In industry, this sort of generalizes what people often call by A/B testing. So this is a blog post from my friend Matt Gershoff, who has a company that does A/B testing as a service, and trying to explain it to people from industry, he says, if you do an A/B test where you try 3 different things at random for 5 weeks, then at the end of it, you hold a meeting and then you decide, okay, I'm just going to roll out option A to everybody. So there's 2 different things that's bad about that. One is you left a lot of money on the table because for weeks 1 through 5, you weren't serving up to people the thing that was better. And the other thing that's bad about it is you had to have a meeting. So you could just not have a meeting and instead just let go and let mathematics decide what is the thing that seems to work, and then with higher probability serve up the thing that seems to work. So this is a language that seems to work for our non-technological collaborators. If you want to think about that mathematically, I'll tell you the simplest examples of bandit algorithms just so you can internalize it. Trust me that what's actually used is much worse, but as a simple idea of what's happening, you could imagine that with probability epsilon, you just do something at random. Let's say you have a blue button and a green button and a red button, or you might have give somebody the paywall or not give somebody the paywall. At random, with probability epsilon, do a totally random thing. With probability 1 minus epsilon, do the thing that is your empirical best estimate so far. That's why there's a little hat on mu, is because you've estimated this payoff from data. It was realized around 2002 or so that you could provably show that an optimal algorithm, optimal in a sense I don't have time to get into, is instead to find the treatment or the arm that has the best value of the expected payoff plus an error bar with a term that grows logarithmically in time and decreases by 1 over square root of the number of times you've done different actions. A much older algorithm for this is simply to use probability. So this algorithm called Thompson sampling from 1933 is do the thing that is with probability P of A, the best thing you could be doing right now. So make a model that actually estimates the payoff of every different treatment, and then choose a random action with a probability drawn from that modeled out probability distribution. So that requires you to be willing to write down two models. One, a parameterized model for the probability of whatever your reward is, given everything you knew before you made the decision and given which action you took. And you need to be willing to write down a prior distribution for your parameters, which makes you Bayesian. Some people are not comfortable with that, but it turns out to be very useful to be willing to use the laws of probability. Again, I said in passing that this is actually a very old idea. It's fun to go back and look at the original paper from 1933. It's even more fun to look at the citation count for that paper, which is 0. This paper was published in 1933, and nobody paid any attention to whatsoever until around 2010, when people in Google and Microsoft and other companies realized that this is actually a very good idea, and it works really well, and it has some provable guarantees. And for me, as an academic, I like looking at this graph because sometimes I have a paper and I really love the paper. And I just think, well, maybe if I wait another 80 years, then people will discover the paper and they will cite the hockey stick. Anywho, what does this mean in terms of simple math? So as I said, you choose an action at random drawn from the probability that this action is the best action. That requires you to be willing to write down a probability distribution. Or there's fancier techniques. You can replace this with bootstrap sampling. If you don't like math, you can use Monte Carlo. And then as you draw new parameter values from this distribution, then it gives you a way of choosing a random next sample. These algorithms turn out to work very well and to have provable guarantees for why they work so well. Okay, so you can do this over and over again. In the simplest case, just imagine you have 2 coins in front of you. All you have to do is update the number of times you flipped each coins, and then the number of times that you found heads or tails with each one of the coins. So it's a very simple to state algorithm. The pseudocode is only 3 lines long, and it works. Okay, so that has been the way we've approached recommendation system, is not in terms of matrix completion or any of the ideas that I think were the ways people thought about Rexis 15 years ago, but to ask what thing are we optimizing, which is not clear. So there's also this sort of alignment problem between us, the data scientists, and our editorial friends, about what is the thing we're trying to optimize, and once we've aligned on what we're optimizing, then we can leverage mathematics, right? We can use tools from as old as 1933 to turn the thing that they want into a stochastic optimization problem. It can be very different for different types of content. So I showed you earlier this blog post from Anna Konen about using contextual bandits. Contextual bandits, by the way, is a bandit, but where you're allowed to use some context. The context might be the entire reading history of the user. Or it could be how many people have clicked on that article in the last 15 minutes, right? Because again, in the news business, articles are supposed to be new. And so as articles become not new, you effectively have a dynamic regime in which the laws of physics are changing all the time. A different type of content for which you might want to do this at the New York Times is, for example, cooking content. So again, at the New York Times we have articles, and articles have been sort of coin of the realm since 1851, but now we also have games and recipes and product recommendations and sports stuff and audio content and video content. There's actually a wide variety of different types of content with which people interact in different ways and which are surfaced to people in very different ways. So for example, cooking content is a set of structured recipes with ingredients, they're called. And people may have different affinities for different ingredients, and they have different seasonalities. People are interested in, pumpkins at certain times of the years, and we can learn that from the data. So this is a blog post about how we treat cooking as a different type of recommendations by Celia and Kaylee, who are the authors of this blog post. So if you've never looked at cooking recommendations, cooking recipes on the New York Times, I encourage you to do so. You will find things like highly editorially curated things like what to cook this week. So here's somebody who has a newsletter, and Melissa Clark has made a recipe, and there's a set of things that are thematically related, and it goes out as a newsletter, but it also goes out as a digital experience where we can make recommendations for what we should put on that digital experience. And again, you might be seeing this on the web, or you might be seeing it in the mobile web app. How might you think about this? Well, in some space, right, there are certain recipes that are closer to each other. The way we attack this is a way that you'll have familiar from the rest of the talks today, or from walking down the street, which is using embeddings as a form of representing content. The content is structured. We can leverage all sorts of embedding tools, including ones mentioned in previous talks today, to represent these recipes in such a way that, for example, this fruit caprese and this whole bean salad are close to each other, and yet miso soup is somehow in a different place in the vector space. And then we can ask the question, okay, well, where would we put this user in this vector space? A clear way to do it, arguably getting back to, we mentioned a lot of history in the last talk, arguably ideas from Jerry Salton in the early 1960s of Dr. and, cosine similarity between things. Once you have a set of vectors, there's many ways to just say these vectors are close to each other. And so we've tried them out in many different ways to say, how do we say that the reader's history, for an appropriately summarized summary of their history, is close to these recipes in some embedding space? Turns out to work. The other thing to keep in mind is working with our editors to figure out what are the right features that go into a contextual bandit. Again, once you're working with an embedding space, you've sort of given up on interpretability, but they're very high dimensional, they capture a lot of semantics. You can also build embeddings based on somebody's history, so you can have article embeddings, you can also have user embeddings. There's all sorts of ways to capture what somebody is all about in a high dimensional embedding space. We also need to work with our editors to figure out what is the reward that we should be optimizing. And I mentioned in passing also that unlike news, which generally is of interest right now and then is not of interest in a few hours, cooking can be of interest to people for a long, long time, but often is quite seasonal. For example, in season near you might be summer, vegetable Niswa salad, right? But at another time of year, people are not as interested in it. So we have to learn from the data, how does interest in different objects change, in addition to learning how to embed the object, how to embed the user in such a way that a contextual bandit can maximize some reward. Okay, that problem of how to do things in such a way that we are optimizing the right reward is even more forefront when it comes to news content. So using algorithms to optimize cooking is one place where we can do a lot of experiments, and when things go wrong, it's, a cooking editor says, well, that thing doesn't really seem to cohere with everything else. Things are much more carefully controlled when it comes to news content. So I showed you that in 2011, the New York Times started a recommendation engine in the form of a structureless feed in the lower right-hand side of the front page. That is not the way content recommendations are done today, and for several reasons. One of the reasons is we're thinking about what is to be optimized. So the recommendation problem is not like TF-IDF or other sort of similarity. It's really done as an optimization problem. That means we need to work with editors to think carefully about what we are optimizing. The other is that the pool of content is not, everything that's been published for the last 30 days presented in a structureless feed. It's much more about thinking about the experience from 1851 where somebody had a newspaper and they had a job to be done, and they would go to a certain section of the newspaper for that job to be done. So a reader might be interested in hard news, they might be interested in lifestyle content, they might be interested in opinion. And if you think about the experience of the dead tree that is a newspaper, right? When the person goes to section C or section B or to this particular page, they know what job to be done and what content they expect to find there. So a lot of the digital iteration with readers for the last 15 years has been publishers and readers sort of effectively training each other on what are the jobs to be done by the reader, and then how does the publisher present content in a way that is navigable, has discovery, allows people to find the content that meets their need. So a good blog post about this was this blog post with Jeanette Young, talking about how to incorporate editorial judgment into the algorithms. Part of the way to think about this, and this is generic to almost any company that's doing content recs, is careful thought about what is the pool of items that is eligible to be recommended. Ranking, an earlier speaker today mentioned that many of these problems map onto either classifiers or ranking. So ranking the content in such a way, and then any sort of finishing function, because, for example, editors might have preferences about which particular ensembles of stories are presented in one particular widget. So programming and winning the trust of the newsroom has involved careful co-creation of pooling algorithms, ranking algorithms, an agreement on what is to be sorted, or what is the score to be sorted, and then finishing. How do we decide what rules they have and how do we respect those rules? The recommendation experience is now very visually different. So I showed you in 2011 this little widget on the lower right-hand side. A product leader from Netflix came and gave a talk at the New York Times in 2014, and he chastised us and said, why do you put your recommendations down in the ghetto of the lower right-hand side, right? Your recommendations should be all over the place. Part of it was to think carefully about what are the different types of content we want to recommend. hard news, features, which could be wellness content or something else, repromotions of old stories that the editors think are dutiful stories that should be told even though they're not new. Sub-brands can refer to The Athletic or Wirecutter or cooking. How do we present those in different ways? And if you look at the homepage, you'll see that there's different widgets with different types of content in those different widgets. They don't really call them widgets, I call them widgets, but different locations. Another way to think about those locations, though, is jobs to be done for the reader. So the reader is looking for different types of content. The other thing that we've done, which is more of an infrastructure thing, is to make it possible for editors to do this on their own. So we've provided tooling to editors so that they can define a pool of content and they can say, go. Within this widget, recommend anything from this pool of content that we determined. Which may sound easy, but editors are not necessarily Python people. So building out tooling so that the editors can easily define for themselves a new package of content when something big happens. The Queen dies or Biden drops out of the race. When one of those things happens, editors or journalists will write many, many stories. And those stories will become a package, and we serve those package of stories up in a new editor-created widget so that they don't even have to bother us, which is exciting, not because we find them bothersome, but it's just like a success when you've built something that editors can use. Deepak earlier today said, how do we amplify humans rather than replace them? And that's been part of the story there is, how do we do this in such a way that not only do we not replace the editors, because arguably that is the moat for the New York Times is the editors, but also because it's unlikely for the editors to feel comfortable with the algorithms if they feel like they're being replaced. Instead, we worked with them to work on what is the reward. So the reward is actually a balance between how much engagement the article is going to get and an editorially important score. And the editorial important score does involve some subjective design choices. It involves iterating with editors. So it could be asking editors to just rank stories. So we did some of that and tried to learn from the data. What is it that makes an editor think that this story is important? Part of it is you get much more digital exhaust by looking at how editors promote stories, because that's what they're doing anyway. So once you have a lot of exhaust about which stories get promoted how, you have a lot of signal for that story, how important is that story, but also some predictive model can tell you, okay, based on this type of content, we think this is how the editors are going to promote that story. So we combine that with the Bandit so that the Bandit is not just optimizing raw clicks, and that involved a lot of co-creation with the editors of a balance between editorial importance and engagement so that we get Timesian ranking as well as driving the engagement measures we wanted to drive. Okay, so those are a couple of problems. I'll close with some lessons learned, building on the lessons learned from previous speakers. One is this statement about prescriptive rather than predictive. Again, for people who are coming from a company that does reinforcement learning, you will not be surprised that reinforcement learning is a good idea. A previous speaker said it today, reinforcement learning is a good idea. For working with people who are not necessarily coming from a machine learning background, it's useful to explain to them that just describing what's going on is a important but different skill set from the skill set of what will happen in the absence of treatment and the skill set of learning what is the optimal treatment to drive an outcome. And here I'm standing on the shoulders of Gartner management consultants. So rather than try to make up some new vocabulary for that, they just said, look, here's a blog post from Gartner, so it must be true. No, so they already have a language for why it's more difficult, but it's also more valuable. If nothing else, it's difficult because you have to align with people on what are the signals that might matter, what are the levers you're willing to pull, and what is the thing you're trying to optimize, which is harder than just clustering your users or something you might do under description. I consider that a playbook for KPI mindset. So key performance indicator mindset at any company is align on the KPI that you want to go up, and by align I really mean with people, like get people in a room and just agree, like what number do we think quantifies our success? Align on the levers you want to pull to make that KPI go up. Are you trying to give people sales? Are you trying to change the product? Are you trying to recommend different stories from a different pool? And then do some sort of explore, which could be a randomized control trial, and then do some sort of exploit. And the exploit could be reinforcement learning, Q learning, could be targeting with supervised learning, it could be a bandit, as I described, irrespective of which design you use, because doing supervised learning where you reweight the training data is not that conceptually different from a bandit. You'll use different mathematics, but they all are in this paradigm of exploring and exploiting. And if you're in a business like the news, where the laws of physics are constantly changing, you need to have some iterative understanding of exploring and exploiting. That could be a bandit, or it could just be an always-on RCT along with a targeting policy. Another lesson learned is to revisit from, 8 years ago, this great blog post by the Romanian data scientist Monica Rigatti, who formerly of LinkedIn. At this point, she wrote this blog post when she was at large doing consulting, and she kept saying the same gospel and over again to people in Silicon Valley. So she finally just wrote this blog post about the pain of companies hiring an AI person first. And she said, no, you are not allowed to hire an AI person first. An AI person first can do like a provocation, but they're not actually going to be able to integrate into your process and your product until you've built the fundamentals. You need to track data correctly. You need to have good ETL. You need to have the data engineering solved. Then you can start exploring your data, realize what pathologies there are in the data. Then you can start thinking about the descriptive analytics and what's actually happening. Then you can start thinking about the basics of prescriptive learning. A/B testing and then rolling out the winner is a form of explore and exploit. And then you can think about fancy AI. It's fun to revisit this blog post 8 years later because AI in 2017 basically meant deep learning, like really good supervised learning. In 2023, AI meant like a chatbot based on what people were excited about in 2023. And in 2025, you're starting to see this thing that looks a lot like 15 years ago when you would go to a hackathon and really ambitious and brave full stack developers would use like 6 different APIs and put them together and make a website, like a pipeline of these APIs. Only now, one of those APIs is a stochastic parrot. One of those APIs is a thing that's really, really smart and has a stochastic output. And still you see people doing these AI developer tools where there's an orchestration layer, which is an LLM, and it's part of a larger system. So AI can mean AI, if somebody says they're doing AI in 2025, they could mean good old-fashioned machine learning, they could mean trading an LLM, or they could mean they're a full-stack developer who uses a bunch of APIs, one of which is an LLM. And we heard a lot about that from Dan Roth today, about how to integrate LLMs appropriately into a larger system. Another lesson to learn is the hype cycle. I think part of that is from Dan Roth's talk this morning, is some new thing, and we're very excited about it. We have some period of irrational exuberance. Then we get sad because it doesn't do everything that we hoped and dreamed it would do. And eventually we all get to what, I think this is also Gardner. Yeah, Gardner called the plateau of productivity, or what I might call rational exuberance. Eventually we all need to get to the point that we understand what it can and cannot do. This has been true for artificial intelligence since the 1960s. People writing papers about what AI cannot do and can do. The inefficiency here is that generally everyone you talk to is at a different point on this hype cycle at the same time. So it's very difficult to align on what the technologies can and cannot do. I guess the other lesson learned is that we've built up this team with people coming from a variety of backgrounds. This is a somewhat out-of-date slide, but there's people here from astrophysics, cognitive science, geophysics, biophysics, business, chemical physics, political science, proper molecular biology, computer science and databases, fMRI. I could name more. Every one of these people is coming from a different field, which has been very useful for building up a team that's small by some company standards and has built out a lot of stuff that drives a lot of value. If you want to know more, I wrote 2 books during the plague because I wasn't going out very much that tried to capture a lot of the lessons learned. The book on the left is more about the history and ethics of data. I'm a fan of history, although I only touched on a few historical elements today. And the one on the right is more for practitioners with Alfred Spector, Peter Norvig, Jeanette on some of our lessons learned actually putting data science to work for building products. And with that, I still have a bit of time for questions. Thank you very much.
Hey Chris, good to see you. My question is posed wearing your hat, your New York Times hat. I've spoken to a number of journalists and editors over the last few years about the role of AI and its impact on labor displacement, in particular in the journalism space. Now, some have argued that it can amplify and make journalists more efficient. So not all labor displacement is bad. And you said you were a history buff. And so we've seen technology have these kind of labor displacement related issues crop up When the internet boom, before that, the automation, industrial revolution, and so on. So I'd like to hear your perspective of that from sort of the journalism space and related to what you were just talking about. Let me know if I need to make a question here.
No, the question is clear because it's a question that comes up a lot externally and internally. I have only speculations, which are very risky. Or maybe I'll start with an emotion. So journalism is good. I would like it if journalism finds a way to continue to have a repeatable, sustainable business model for the next decade. I think the case of AI and its impact on roles, I think, is much better said by economists. So here I'll do the academic thing and say that's outside my field of expertise. But I can quote economists who talk quite a bit about roles and tasks. Right? So I was at an event recently where Alfred was talking about a job, right? A job title will have many different tasks associated with it. And almost surely, as technology evolves, some of those tasks will be automated or made more efficient, and then the role will change because the set of tasks that are mapped onto that role or that job title will itself change. And that's certainly clear. I mean, the job title data scientist in 2009 is different than the job title data scientist in 2025. You are absolutely right, though, that it directly ties into journalism for a couple of ways. One is the technology about which people have been very excited since late November 2022 is a technology that generates words, which in the abstract is the same thing that journalists are really good at, right? And again, I think Dan Roth did a great service to us today when he said, one of the lessons has been, wow, it is surprising to us how easy it is to get a computer to spit out something that parses linguistically. Arguably, we should not have been surprised. Mark V. Cheney and arguably Claude Shannon showed this in 1945, right? That if you have a corpus of text, you can generate things that are surprisingly similar to language. What's happening now, though, is that is coupled to two economic forces. One is the incredible disruption of journalism, especially 2000 to 2015, which has just eviscerated journalism as an industry. And the other is a ridiculous abundance of capital around one particular technology, which no one can ignore, right? It's just the abundance of capital being thrown at companies and now individuals is unprecedented and eye-popping. So I think that really amplifies people's feelings, and it makes it difficult people to rely on the sort of slow view that you hear from Hal Varian and others, that your role will be defragmented into different tasks, and technology gradually and naturally replaces some of those tasks. I do think it's a good idea for everybody to know what things can and cannot do, and that's a historical view, right? Arguably Dreyfus was writing about this when he wrote What AI Can and Cannot Do in 1965, I think. So I think it's useful for us, all of us, to have a good sense for what AI can and cannot do. The answer to which is changing, every day. Right? Every day, an ensemble of models is being released. We all look to leaderboards or LinkedIn posts as people just sort of empirically discover what these things can and cannot do. So I don't have a really good predictive answer. My hope is that journalism finds a way, and my suspicion as a technologist is that people will benefit from learning what the technologies can and cannot do and getting to that sort of rational exuberance part of the curve. I still think that having human journalists is a good idea for a variety of reasons.
Hello. So you were mentioning that after ranking and doing recommendations, you take a lot of time to kind of align with what the editors want in terms of guardrails. And the question, since LLMs weren't mentioned much, is the next step not just aligning guardrails, but aligning taste and actually having a recommender system that represents kind of editor's taste? And could we see them taking more and more, again, functions of the editor as that goes deeper and deeper?
Almost surely, but I don't see a place where you don't have editors in the loop. So human in the loop, but in particular editors, like the people who are really good at looking at content. So even if these people are using spell checkers, sentence completions, summarization tools, I don't see a place where we're not going, at least the New York Times, is not going to continue to have editors checking on everything stylistically. Certainly, you could imagine something that's trained on the New York Times corpus so that things are fine-tuned to produce Timesian language. That's not science fiction. You can easily imagine how to do that. But I think there's still going to be editors who are saying, we want to manually verify anything that's coming out of a spell checker or a sentence completion or an automatic summarization.
Thanks. Do you have any metrics for informational importance other than what editors think are important? Because it seems really, it would be nice to have as we shift to generative question answering, metrics for informational importance. Like not just what people want to know, but what they need to know.
Yeah, so I think wearing my hat as somebody affiliated with New York Times, I still think editors are the best way to do that. If I were to take off my New York Times hat and say, for content more generally, doing that at scale, there's plenty of ways to do it, including asking people, right? Like there's a lot of sort of survey infrastructure. There's many companies that will, do surveys of people and see, did this inform you or not? There's also task completion, so you give people something, an instructions, and then you ask them to do a task. I think we still need humans for that. So I don't know that there's a sort of the equivalent to a blue score or some sort of automated thing that I would run it through to say, like, how important was this information? I think for now, at least humans are still needed to do that task by task. But the Timesian answer is, it doesn't make sense to replace the editors because the editors are the moat for the New York Times. And so they are really the keepers of what is Timesian style, what is dutiful, and that of course is changing all the time, right? It's not like they are encased in amber and they're still saying the same things they would have said in 1851. It's a reasonably self-critical cohort, the cohort of all journals, not just inside the building, but just like other forms of peer review, like they notice it when they get scooped, they noticed it when they get critiqued in whatever their appropriate professional publications are. So that is a dynamic crowd with their own dynamic norms.
Hi, Professor. My name is Shrader. I work at Amazon, but I'm also a Columbia alum. I'm curious about GenAI adoption at New York Times, specifically around two things. One, do journalists use some sort of GenAI retrieval ranking for journalistic research? And then secondly, what about actually writing content? And in a world where so-called AI slop is increasingly prevalent, New York Times is supposedly the gold standard for human content. Are you resisting the GenAI change, or is that a future that New York Times will also adopt?
Those are both great questions, and they are kind of corporate communications questions. So the question about what is the state of GenAI usage in the New York Times, to that I'm going to refer you to nytco.com, in which there's press releases about the New York Times policy about using GenAI in the newsroom, again getting back to the church-state divide. In terms of how does AI slop impact the value of New York Times journalism, our CEO was just interviewed by the Aspen Institute just last week. She said a whole lot of stuff about the role of information. I don't think I could say it better than she did. So, I mean, at a high level, I think having content is a good idea and worth paying for. AI slop, I mean, even using the term, it reveals how easy it is to generate content. You can download your favorite model right now, and you can ask Cursor to write programs that will generate slop for you. It's quite easy. But in terms of how the New York Times feels about it, I don't think I can answer things better than our corporate communications branch has. So I'll refer you to nytco.com for official statements.
Fair enough. Thanks.
Yeah, hey, thanks for the talk. This maybe is related to the last question. I know New York Times is strongly, guardrailed against having any Gen AI content come out in their articles, and they're written by humans. Do you think there's any capability that may come along that would, change that stance, or what's the upside?
I mean, if you were to imagine going back in history, spell checkers are a good idea, right? So you can imagine it being 15 years ago and asking, should journalists be using spell checkers, right? Should journalists be using sentence completion? At what point is there not a gray, but a hard line where people say, this is too much AI to help me write this document? Because again, there's a craft that I have, and the craft is not that journalism craft. I don't want to opine too much about where that line is between spell checker versus, write me an article about this thing that happened. The New York Times, I don't think, has come out and say we will never use Gen AI. It has a much more nuanced statement. which I think originally came out in the summer of 2024. And so again, like in terms of corporate communications, I think it's better for me to refer to that rather than me try to regurgitate what the nuanced position is on Gen AI. Okay.